Right, we're out here today to have a chat about gravity. It's that one force of all of the forces that we're most familiar with. We all feel gravity every day, and it feels strong. Interesting to know then that of the four fundamental forces, gravity is in fact the weakest. That in fact, when you think about it, every single atom in the whole of the earth is trying to pull you down, but you can jump. Your body can overcome the force of gravity. It's not that strong. It's the weakest of the forces. And so, gravity, how we experience it on Earth, is that we have an acceleration of 9.8 meters per second squared downwards. When we're writing it, we write G equals negative 9.8. That negative tells us about the direction. That tells us that gravity is directed down. In our world of mechanics, we build up an idea that things to the right are positive, whereas to the left is negative. Up's positive and down is negative. So when we see positives and negatives, we have to always be thinking about direction. We can use a unit for gravity of meters per second squared, or we can use newtons per kilogram. How many newtons does each kilogram of matter feel? And that's because every object, irrespective of its mass, is going to feel the same acceleration. That means that a bigger mass is going to have a bigger force so that it has the same acceleration. And we can use this acceleration to solve problems about falling. Let's have a go. So the kind of basic problem that we might have to solve is the sort of problem that you're solving in your own head when you head down to the top rocks and you stand on the highest of the highest points and wonder, how long is it going to take me from when I jump until when I splash into the river, and how fast am I going to be going if I fall 17 meters? That's quite a long way, remembering that 3 meters is like one floor in a building, therefore 17 meters, that's a 5 or 6 story building that you're jumping off. Just how long is it going to take to fall that far? Now I want you to, thinking back to our kinematic equations, we should be able to identify the initial velocity, final velocity, acceleration, distance and time. 5 different quantities. See if you can work out. We've got final velocity and time. Pause the video, make sure that you can identify those 3 remaining quantities. Hopefully you worked out that the distance was 17 meters, because that was pretty obvious. Acceleration, sometimes we have to nudge ourselves to remember that it's negative 9.8, and the initial velocity, we often have to carefully read the problem, but because the picture shows someone standing on the top of the cliff, we know that the initial velocity is 0. They're not falling up, they're not falling down, and we're only thinking about the vertical velocity. Choose a kinematic equation and solve for VF. Choose a different kinematic equation and solve for T. Pause the video and we'll meet back here once you've done that. So you might have chosen the VF squared is VI squared plus 2AD equation, and you might have rearranged it like that. But you might also have run into maths error trouble here, because negative 9.8 and 17 puts a negative inside the square root, and your calculator doesn't like finding the square root of a negative number. doesn't know about imaginary numbers. And so what we had to realise was that the distance, 17 metres, that's a distance downwards. Remember that downwards is negative, and if we pop in a negative 9.8 and a negative 17, they cancel each other out, and we do get an answer of 18.3 for the speed. 18.3, well, it's a bit quicker than 50 kilometres an hour. Now, there were lots of different ways that you might have gone about solving this problem, because knowing VF already, we had the freedom to use almost any equation we liked. However, I always like to use one that doesn't use a value that we've calculated, because that reduces the chance of us making a follow-on mistake. But however you did it, you should have ended up with 1.86 seconds as the time to fall.